Hello, welcome to Chemistry A. This is Unit 2, the periodic table, Day 4 notes. Today we're going to talk about trends in the periodic table, trends in atomic size, trends in ionization energy, and trends in electronegativity. The good thing about trends is because if we can figure out what the trends are of those three categories, we do not need to memorize all 118 elements in the periodic table. So before we begin to talk about individually those three categories, let's discuss quickly what a trend is. A trend is an overall pattern that is going to develop in the periodic table. The periodic table, remember, is split into groups, which run up and down, and periods, which run left to right. So within each group there will be a trend, and across in periods there will be trends. Trends are an average, an overall pattern of how things are going to work. That does not necessarily mean that in every case that trend is going to be from element to element, but the overall trend will be in one of these two directions. So let's get started. First of all, let's talk about trends in atomic size. We use atomic radius to estimate the size of the atom. Now remember what radius is. Radius is 1/2 of the distance between the nuclei of two atoms of the same element when joined. So put two elements of hydrogen together, for example, put them right next to each other, and then we measure from the nuclei of one to the nuclei of the other, and half of that distance will be the atomic radius or size of one of those elements. So let's take a look. In a group, the atomic size or radius increases as the atomic number increases. What is increasing an atomic number? We know that that increases the charge on the nucleus because we are adding protons. So as we move down, as we go from hydrogen to lithium to sodium, we are adding protons. And as we add protons, we are also adding energy levels. Take a look at hydrogen. It has one energy level. Lithium now has 2. Sodium now has 3. Take a look at the increase in protons. Hydrogen had 1. Lithium now has 2 more protons to make 3. And now we've added 8 more protons to lithium to make a sodium atom. So they have increase in size due to increase in charge and increase in occupied energy levels. Now this will affect the atomic size in opposite ways. Increase in positive charge actually draws those electrons closer to the nucleus. Time out, you say. If it's increasing the charge, Mr. Pack, and there are now more protons and electrons and drawing it closer to the center, shouldn't the size of the atom decrease as we move down? And I would say yes, except we are increasing in the number of occupied orbitals, orbital shields, and there's more electrons in that highest occupied energy level, and that is causing a disconnect. That's causing the electrons to push away a little bit, actually. So increase in the number of occupied orbitals shields electrons in the highest occupied energy level from the attraction of the protons in the nucleus. So let's take a look at sodium over here. We have these extra energy levels. These electrons are pushing away slightly at the other electrons. Therefore, it pushes them a little farther out, so it's pushing them away from the attraction of the nucleus of those protons, and that's called the shielding effect. The shielding effect is greater than the effect of the increase in nuclear charge, so the atomic size increases. So once again, shielding effect, that outer layer is pushed away from the repelling of the like-charged electrons, therefore it makes the atom actually increase. How about trends in atomic size? How about through the periods? Periods, remember, move left to right. Atomic size of the radius decreases across a period from left to right. Well, why? Each element has one more proton and electron than the element before it. Since the electrons are adding to the principal energy level, the shielding effect remains constant for all elements in the period. Increased nuclear charge pulls the electrons closer, decreasing the size of the atom. What that means is that as you go from left to right, yes, you're adding another electron, and yes, you're adding another proton. But all of those are going into the same energy level that already exists. Therefore, the shielding effect remains constant. So as you move left to right, we have more electromagnetic attraction between the P's and the E's. Therefore, the size of the atom shrinks until you jump down to the next level, and that's when we have a new energy level, and that's when we start getting the shielding effect. Okay? So that's trends in atomic size. Now, a reminder, when we talk about ionization energy, electrons can move or jump to higher energy levels when atoms absorb energy. Sometimes electrons can overcome the nucleus attraction, so they can jump out, okay? And they leave the atom, actually. So that is ionization. Ionization energy is the energy that is required to remove, to pluck an electron from the atom. The analogy that I use is a tug of war. We do know that somebody is pulling on one side, but just because they're pulling with all their force does not necessarily mean they're going to pull that other side closer to them. It's the side that has the greater pull. So pulling that electron away, that electron wants to stay in there, but if that force on the outside is greater to pull it away, then it will leave. And then we can measure that. We call that the energy that is required to remove the electron. In a group, ionization energy decreases from top to bottom within the group. Why is that? Because as size of the atom increases, nuclear charge has a smaller effect on the electrons in the highest occupied energy level. Therefore, less energy is required to remove. So the farther away those electrons get from the center, the easier it is to pluck them away. So we need less energy to do so. Okay? Within a period, ionization energy increases from left to right across the period. Why? Because of the nuclear charge, which increases, and the shielding effect remains constant. Therefore, an increase in the attraction of the nucleus for an electron. Therefore, more energy is required to remove the electron. So as we look over at the far right of the periodic table, we're talking about fluorine, chlorine, and those atoms. They have a much smaller size, therefore those electrons are closer to the nucleus, and since they're closer, you need more force to pluck them away. Okay? Let's talk about trends in electronegativity. Electronegativity is the ability of an atom to attract electrons when in a compound. This property can be used to predict bond type. Okay? So within a group, electronegativity values decrease from top to bottom within a group. This has a lot to do with the same reason as ionization energy. Is what causes this. So the electronegativity values decrease from top to bottom within a group, and in a period, electronegativity values increase from left to right across the period. Trend is only for the representative elements within the period. Okay. Now here is a trends summary. As you can see, we have our S's, P's, D's, and F's. You've seen this before. This is our periodic table, and as you move down, we have atomic radius, electronegativity, the shielding effect, and the ionization energy decreasing. And then over here, atomic radius, electronegativity, shielding effect, and ionization energy. If you can memorize these trends, you'll not need to memorize the periodic table. You will have to tell me, though, which atom has a higher electronegativity. That one or that one. And those are the things you're going to have to answer questions to. So you're going to have to be able to apply it, not just memorize it. Thank you, and have a good day.